Okay, for today, it's basically day 2 of circle trig. What did we learn on day 1? You learned about what a radian was. Do you remember? Let's say that the radius of this particular circle is 8. Would you please try to sketch for me approximately what a radian would look like as the central angle, as in the angle that's at the center of a triangle? I'm going to, it's not even just a triangle, it's more like a wedge of the circle. Don't remember this? Were you here? That makes sense then. All right. So, I hope you drew an angle that was in the neighborhood of 60 degrees. Remember that? Ooh, I heard 57. You're even closer. That's right. It's about 57 degrees. All right. So, why? Because then this side, the arc, is also equal to 8. That's how you get a radian, is when the arc length, that curvy side there, is the same as the two radiuses. Then you have found a radian. And that radian, that angle, is 1 radian. Then, this will help us with this formula. S equals theta r. I call it the SOAR formula. And I remember me saying it was kind of annoying because it's the SARC length. S is really the arc length. The arc length is equal to the theta, which is how many radians it is, which is 1, times the radius. In this case, it's 8. So that means our arc length would be 1 times 8. And notice that this was in, let's say this is in inches. Do you get radians don't have units? If they did, then it'd be, let's say that was like degrees. Then those would be like degree inches. That'd be weird. Okay. So there's no radians on this thing. And this always has to be in radians. And this is always the radius. All right. Now, let's do one backwards where I say the arc length is 12. Either I could tell you the radius, or I could tell you the angle. Which do you want? Radius, okay? I'll give you the radius. If that's 12 and this is 10, would you please figure out for me, let's say these are in feet this time, figure out for me what is the angle. Hint, use the SOAR formula and solve. I'll pause for a moment. I'll give that a try. Okay, you should have just said S equals theta r. That's duh. I just told you to use that formula. And did I tell you the arc length? I did. It was 12. Did I tell you the theta, the angle? No, so you should leave that as a theta. And then that radius was 10, and so hopefully you can solve and get 12 tenths. What is that then? That's an angle. And that's weird because it's some decimal, like, well, isn't it 1.2? 1.2 watts. Radians. Each radian's about 57 degrees. So it's more than 60 anyway. What is it, like 65, something like that? All right. How could you tell exactly how much it is? Well, then we have to be able to change radians into degrees. So this is 1.2 radians. How do I change it into degrees? Well, I either want the degrees on the top or the degrees on the bottom. You want them on the top, because if you want your answer in degrees, then you want the degrees on the top. And this is always 180 over, what was that thing that 180 went with? Pi, very good. So then pi is really a number. Remember, it's 3.14. So then, really what you're doing is 1.2 divided by 3.14 times 180. It's like a percentage of 180. And how many degrees was it? Somebody got it? 68 degrees. Okay, cool. All right. Now that was in degrees. If you had just stopped right here, that's a perfectly good answer. Reduced 1.2 or 12 over 10, which, you know, it could be probably simplified more. I suppose I could say 6 over 5, 6/5. That's an answer in radians. You just don't like it because you're thinking that doesn't seem like it's degrees. Well, it's not. It's radians. 6/5 of a radian. All right. Now we got to get better at those. Like right now, I bet you if I said 7 pi over 6, a lot of you would have no clue what I'm talking about, and you need to know where that is. 7 pi over 6. Well, let me give you a hint. It's 7 times as big as 1 pi over 6. Do you get what I'm saying? This is 7 pi over 6s. A whole bunch of pi over 6s. Well, what are pi over 6s? Please, please, please memorize this. 30 degrees. And if that hasn't already got stuck in your head, do you get pi over 6 could be translated the long way into multiplying it, or by multiplying it by pi over 180 or 180 over pi. In this case, it's 180 over pi because we want the pi's to cancel. And then I can get 180 divided by 6, which is 30. Okay, so you can do it the long way, but there's a few you should really just know. Pi over 6 is 30. So then, what's 7 pi over 6s? Well, it's 7 sets of 30. 210 degrees. Does that make sense? So there's 180. 210 will be a little bit further. So it's like there. But that's thinking in degrees. I'd love to get you thinking in radians. Do you know when they say that when you start dreaming in German, then you really know how to speak German? Have you ever dreamed in English?
I don't remember.
Don't remember your dreams? Okay. Then you got to be woken up at just the right moment. And then you will remember your dreams. So you got to set your alarm for just a little earlier because you're probably dreaming and then it'll wake you up. Anyway, has anybody ever dreamed in a foreign language? You have? Which language? In German. Okay, cool. See, then you can tell you've reached that, definitely a level of, I don't know if I want to say perfection, but you're at least fluent-ish. Oh, there we go. Really?
Yeah.
They actually spoke German at home. That is cool. All right, didn't know that. All right, because I knew both your parents only as English speakers, so I didn't, All right. So, I don't expect you to be dreaming in radians. But I need you to try to think in radians, because when I say later, like, where's 5 pi over 3, you got to be able to think about where are pi over 3's and then a bunch of them. So this is 7 pi over 6 was my assertion that we needed to know where that was. Well, where's 1 pi over 6? That's about 30 degrees. It's about like that. Where's 2 pi over 6? Where's 3 pi over 6? About there. Does that make sense to you? 3 pi over 6. That's 3/6 of a pi. That's where pi is, because pi is 180. Do you get how we're about halfway to pi? Halfway there? Living on a prayer? All right, so that's 6 pi over 6. But wait, Mr. Server, that's actually just pi. Well, 6 pi over 6 would reduce to pi, wouldn't it? So if you think about it in counting, you just keep counting. You got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Then 7 pi over 6 must be right here. 7 pi over 6. So that's the spot where 7 pi over 6 would be. Your homework for tonight mostly centers on this, and I want to go past it. I want to teach you enough to do tonight's homework, but then a lot more. Because tomorrow's is tough, and if I can get you thinking about it today, I'm doing a little pre-teaching. Because today could be really easy, but then tomorrow will be really hard. So I'm going to make today a little bit medium hard so that we can do 2 days of medium hard instead of 1 day of easy and tomorrow being brutal. All right, so 7 pi over 6 is this angle. Notice it's a big open angle. It's like a flower that's open past 180. It's like open even further. Okay, it's at like how many degrees? We said it a second ago? 210, because remember each of these was 30, and there was how many 30s? 7 pi over 6 is 7 30s. 7 times 30 is 210. Now I want to think of it this way. That's 180 plus 30 more makes a total of 210 degrees to get all the way there. So 210 is another way to say that spot, isn't it? 210 and 7 pi over 6 are called something. They are called coterminal. You know what terminal means? Basically it means stop. Okay? The terminal is where it terminates, where it stops. If you are terminal, that means you're going to be stopping soon. Okay? So a terminal side is the place where they stop. So I'm going to make you a picture here that I think is worthy of taking a second to just draw really nicely. So I've got my circle here, and I take these to make a really nice, sort of like a clock almost. Okay. Now, if I start here, that's where all angles start. That's about 30, 60, 90. Are you with me so far? What's 30 more than 90? 120, and then 150, and then 180, and then 210. So that's the angle we're talking about. But get that this can form. Sorry, back here. Can't explain that. Do you get that you can draw it this way and say that that was 210 degrees, or that you could say it's in radians 7 pi over 6. Wait, that's really annoying crackling noise. I don't know how to stop it. Something like I got static electricity built up in my cord or something. That's weird. Okay. Anyway, but there's another way to get here. And your homework for tonight focuses on what is 3 ways to write this angle. 7 pi over 6, 210, or what if we went from this way? Any theories on what that would... Aha! A negative angle is now possible. If you had to say it's negative something, would you say it's negative 210? No, it doesn't make any sense. Negative 180 would have made you back here, and so it's obviously less than negative 180, so what do you think? Negative 150. You see why I'm not stopping there? Because that's really all I'd have to do for today. Just teach you how to do that. But it's pretty easy, and we can do more. So I'm going to do a little bit more, and this might be a little painful for some of you because it's going to stretch your mind. But you know what? If you go into the gym and you only lift light weights, you don't get stronger. All right. So that's a 45-degree angle, or at least it's supposed to be. Can anybody tell me what it would be in radians? Pi over 4, very good. How'd you get that? Well, you could say it's 1/4 of the way, and also where pi is, right? Do you get how it's 1/4 of the way there? Does that make sense? So that's pi over 4. So what's the sine of pi over 4? Wait a minute, that doesn't look like a triangle, so how am I supposed to do opposite in the hypotenuse? Sine of pi over 4. Okay, now of course you could use a calculator and type in sine pi over 4, but the point is you can do this without a calculator by knowing circle trig. All right, watch. Sine of pi over 4 needs a triangle. I'm going to make a triangle by dropping that. Remember in geometry you could drop a perpendicular, it's called? All right, well I just made a right angle, which makes this a right triangle, doesn't it? And if that's a right triangle and you understand what that angle is, it's really 45. Then this is really 45. And then, if it's really a 45, 45, 90, I know some stuff. I know, do you remember these? I hope you have these memorized. 1, 1, root 2. Does that ring a bell? Okay. Now I ask you again, now that I've drawn a triangle there. What's the sine of pi over 4? 1 over root 2. Sine is opposite over hypotenuse, isn't it? Angle that we talk about is always this guy, the one at the center. It's called the central angle. From that angle's perspective, this is the opposite, and that's the hypotenuse. All right, what's the tangent of pi over 4? Now that the triangle's drawn, this is easy, isn't it? What's the tangent of pi over 4? Opposite over adjacent, 1 over 1. Yeah, 1. Cool. All right. So what's the sine of 7 pi over 6? Do you remember where 7 pi over 6 was? So what's the sine of that? I know you want to type it in your calculator, but don't do it that way. Sine of 7 pi over 6. Hint. Draw a right triangle by dropping a perpendicular. First of all, figure out where 7 pi over 6 is. It's a place. It's a place on the unit circle. Draw it. And I think you need a partner because this part is tough. So rows 1 and 2. Slide over next to each other. 6 inches apart. Rows 3 and 4. 6 inches apart. 5 and 6. 6 inches apart. Find for me the sine of 7 pi over 6. And I doubt many of you will get it right, but some people will. And if I set it up so you're trying to at least understand it, then when I show it to you, it'll make more sense. Try it. 7 pi, sine of 7 pi over 6. All right, I let you work a little longer than I thought, because have you guys ever heard the old saying, don't just stand there, do something? And as a teacher, sometimes you feel like that's the case, but actually for a teacher, it should be reversed to don't just do something, stand there. Because I needed to let you have some time to like work this out in your head, okay? But at least, how many of you figured out that the spot I was talking about is basically there, and therefore must be a triangle that's basically there? How many of you have a triangle drawn right there? Good, then you got a really good start. Next, did you know that that was a 30-degree angle? Because you had a whole bunch of pi over 6's, and therefore that's another little wedge. That's a pi over 6. And therefore, this is the 1, 2, root 3 triangle. But, there's one catch. And it's the biggest mistake in circle trig. Did any of you think to make one of those sides negative because it's going down? Well, you caught that. Good catch. -1. Why? Do you remember on the XY coordinate system, when you go down, that's negative? When you go left, it's also negative? Was anybody smart enough to say that this is actually negative square root of 3? It is. If I was on a graph with your classic X and Y axes like these, that I have been going from the center, I'd have been going left and down. Therefore, they're negative. That makes sense? So easy to forget, though. All right, last thought. That 2. I heard somebody say to their partner, that 2 can't be a 2 because we're in the unit circle. They're kind of right, but kind of wrong. Did I say that you had to make it a unit circle? No. But if it was a unit circle, do you guys know that unit means 1? And therefore, this should have a radius of 1. And if it does have a radius of 1, do you get that these are just sides don't have to always be that long, right? But if I wanted to make them smaller, I could divide this by 2. Why would I want to do that? Because then it turns into 1. And then I'd divide this by 2, making it -1/2, and then divide this by 2. I know, right there, just fried some people's brain cells, but I don't think you would have minded if I'd have doubled the length of all the sides, right? That'd have been okay, wouldn't it? So can I cut all the lengths of the sides in half? All right, so this is the part that's really going to freak you out, though. Sine is -1/2, and it's right there. The answer to the question is -1/2. Why is it right there? How is that length right there the answer? That's weird. How many of you knew that the answer was -1/2? Because it is. All right. And if you don't believe me, you can always go to your calculator, put your calculator into radian modes, change it to 7 pi divided by 6, and then take the sign of that, and it'll say -0.5. The answer is -0.5. I'm just trying to say there's other ways to test me. You can use a calculator, but so if it's -1/2, why is it here? Why is that the answer? Isn't the answer supposed to be sine is opposite over hypotenuse, right? Well, watch. What is the hypotenuse? So when it's opposite over hypotenuse and the hypotenuse is 1, then it's just the opposite. Get what I'm saying? Sine. So opposite over hypotenuse. But what if the hypotenuse is 1? Opposite over 1 must be just the opposite. So all of a sudden, the sine is the y value. Sine is y. Cosine, take a guess, is the x value. This is where the cosine of it is. And this again makes some heads explode. I should have brought in some paper towels. No. No.
It was just -1/2, and that's why it was -1/2.
It's only when the hypotenuse is 1. You said, is it only when you divide by 2? No, but it's only when the hypotenuse is 1, which is only going to be when it's in the unit circle, because that's when the hypotenuse, also known as a radius, is going to be 1. All right, yes? Okay, let's back up in time and go back to the original, and it looked like that. Okay.
So from 30 it's still opposites there.
It still works, doesn't it? So this other thing that I'm telling you isn't really necessary. And you're right. But if the problem said we're in the unit circle, and then they asked you how long is the radius, you would have said 2. See what I'm saying? Because the radius as we have drawn it is 2. All right. So, okay, so how can I do this to see if you really got it? Let's see if I give you another one, and this time I'm not going to even ask you to do it when it comes to the unit circle. I'm going to ask you to do this one without any numbers. Without any numbers. All right, I'm going to draw some radius here. Okay, and we don't know how big this angle is. What? We don't know how big the angle is? Nope. And we don't even know how long the sides are of this triangle. But do you get we'd have to drop a perpendicular, and so therefore it'd have to drop a line like this. Okay, this should really be touching. I'm sorry, I should have made this a little longer, so I'll cheat. There. Okay. Okay. And if I'm going to generalize this, would you agree that this distance right here, this green line, would be basically x? Okay. That's because it's in the x direction. How about the blue one? What direction is that in? That's in the y direction. What do we always call a central angle if we don't know what it is? Theta. And lastly, we're going to make this the unit circle. What does that tell us? The radius must be 1. Now I'm going to ask you, what's the sine of theta? Such a simple question, yet nobody's answering. What's the cosine of theta? And what's the tangent of theta? I'm going to pause for a minute and let you marinate on that for a little bit. Okay, so sine, well, it's opposite of hypotenuse. Which one's the opposite? Y over hypotenuse, which is 1, so it's y over 1, but can't I just say it's y? Because y over 1 is just y. And then what's cosine? And what's tangent? Do you get why I'm going to say then that tangent is really sine over cosine? If your tangent button was broken on your calculator, you wouldn't really need it. You could figure out the sine of the angle in question. Like you're going to do tangent of 24, okay? You could figure out sine of 24 and cosine of 24 and divide them. That's what tangent is. It's y over x. It's sine over cosine. So later, we're going to be able to say things like, crackly, stop the crackling. You know what? I'm going pre-teaching too far into the distance. I don't want to blow your minds any further. All right. So, eventually, tangent will be sine over cosine, and you'll be able to solve that for sine or cosine or tangent and solve in terms of the other two. So you can say, well, sine, therefore, is this over that. If tangent is sine over cosine, I go a little further. If that's sine over cosine, do you get if I want to solve for sine, I just multiply both sides by cosine? So sine is really tangent times cosine.
Then sine would be, no, cosine would be sine over x.
So no, you've never thought of trig in these ways before. All right, so what you'll have to do tomorrow, not today, but tomorrow, is answer questions like this. What is the tangent of 11 pi over 6? Well, first of all, you never even knew what the heck a pi over 6 was before a couple days ago. Now you got to do the tangent of it in terms of a two-dimensional picture, but it's got positives and negatives But I bet you can do it. I bet you can even do it right now. I'm going to pause for a second while you try to figure out tangent of 11 pi over 6. Just remember your negatives. Be careful with that. I'm going to pause while you give that a shot. Tangent, 11 pi over 6. Hint, 11 pi over 6 is really close to 12 pi over 6, which would have been all the way around to here. So it's not quite that far. Did you get that it was actually there?
Yeah, that's what I did.
Awesome, then you're doing it right. And then that's how many degrees? 30. How many do that much? Awesome. So from there, it's easy. You just have to label the rest of the sides. And I'm going to say this probably 500 times in the next month. If you've got a labeled right triangle, then these questions are easy. So you just have to find where this triangle is, label its sides and its angles, and then the actual question, tangent of the angle, is easy. So let's finish this off. Did you get a side of 1, 2, and the square root of 3? Okay, then you did it wrong. So easy to make that mistake. Negative 1. I got some of you. It's so easy to forget that, isn't it? Because that's going down. All right. I'm just going to label in a couple more angles. That's 90 and that's 60. And then I'm going to ask you the question one last time. What is the tangent of which angle is it? The central angle, the one by the center. Tangent of that, total, opposite, over, adjacent. Did you have negative 1 over root 3? That's what you should have had if you looked at it again, but you'll find out. My gremlin's living in my recording device. Okay, that's actually tomorrow. So what's today? I wanted to blow past what today's was. Today's would have just been name 2 ways to get to 11 pi over 6. Wait. Here's 11 pi over 6. First of all, I got to know where it is. And then what's another way to get there? Remember the negative thing? Negative 30 would have been a good way to get there. 11 pi over 6 is the same as negative 30 degrees because you're going from here, you're going down, and that's negative 30, and then one more answer except, 330. I like it. That works. There's more. But wait, there's more. You can do negative radians too. Did you know that? Negative pi over 6. They all end as in terminate, as in these are called coterminal. Co meaning they share the same ending place. They're all coterminal. That's 4 ways to say it. In today's homework, they typically say they give you one of them, and then they ask for 2 more. So they want 3 out of those 4 ways. Okay, let's do one more like that. Give me some things that are coterminal with 3 pi over 4. First, you might want to figure out where 3 pi over 4 is. And then find me a couple other ways to get to 3 pi over 4. I'm going to pause while we try that. If you want to do the slow way, you can always multiply these by 180 over pi or pi over 180. In this case, it would be 180 over pi. And I don't like this way because it takes a long time, but it's kind of nice to have as a backup. Instead, what I like is this. If I want to find 3 pi over 4s, I should probably figure out where 1 pi over 4 is first, right? And here's 1 pi over 4. 1/4 of the way to pi. This would be 2 pi over 4s, also known as a halfway to pi. And then this would be 3 pi over 4. So that's the one. The other 2 weren't it. Oh, flying eraser. But I caught it. Yeah, thank you. Thank you. Olympics for teachers are coming up soon. All right, so this was 3 pi over 4. Yay. Now wait, Mr. Server, you've been having us draw this triangle over here. Yep. That's called the reference triangle. Because you don't actually make this triangle. Never do. You only make right triangles, and that wouldn't have been a right triangle. See? So this green thing is called the reference triangle. That's part of tomorrow's. But today they would have just said, what's another couple names for that spot? Did you get that it was 3 wedges of 45? So 3 times 45 would make 100 and 135. Very good. 135 was a good answer. Option B, I can do negative 180 plus 45 more. Negative 225. And if you like thinking in radians, a whole bunch of pi over 4, 4 pi over 4 plus 1 more would make 5 over 4. But negative, because it came from this way. Negative 4 pi over 4 plus 1 more pi over 4. Negative 5 pi over 4. All right, last thing. Do you guys remember your quadrants?
Yep.
Last thing, I promise. So what quadrant are we in right now? This line here is the... Where are we? What quadrant? Quadrant 1, 2, 3, or 4? 2. 1 is the first one. Here, I'll show you it this way. I think a pirate designed this because you go around kind of like this in a C. People think the pirate's favorite letters are, but it's actually C.
I'm never going to forget that. Maybe.
It's not National Talk Like a Pirate Day.
What?
Just wait till it is. Okay. Quadrant 1, 2, 3, and 4. Now, I would accept if you said Q2, do you think I will get you mean quadrant 2? But I also accept these if you like them.
Oh, yeah.
Roman numerals. Okay, so you can say they're quadrants 1, 2, 3, 4 this way, or you can call it Q1, Q2, Q3, and Q4. I'm fine with either. Now, some people ask, what about this line that's exactly between the two quadrants? Which quadrant is it in? It's not. It's between quadrants 2 and 3. You get what I'm saying? It walks the line, kind of like Johnny Cash. So how about 270? Think about where it is. Where's 270? Between 3 and 4. It's down here. That's 270. Crickly's driving me crazy. Okay, so anyway, hopefully this video even turns out, but we'll find out. Audio's pretty bad in here. So, do you have... I know, I should tell you what your homework is. Find the assignment that says day 2 on it. I'm about to give up on this crackly thing, but I got to try to make it through the end of this. Thanks for your patience. I'm giving up because I can't take it anymore. Find the part that says day 2, and can you tell me what page that is?
27.
We've got verified page 27. Seems like it says day 2 on it.
Yes, sir.
All right. So, page 27 of the file, and the next page. Those 2 pages, that's it. Do all those problems. Page 27. Would you read me the very first one so that people can see if they're on the right one? What's the first problem say?
We said, it's extra number 9 and then 330.
330. All right. And it says to find 2 things that are coterminal, right? So what's coterminal to 330? My hint for you is start by drawing where it is. That's where 330 is. Then just ask yourself, how else could I have gotten there? Got an answer or a question? Let me finish this one. Negative 30. Yeah, how I did that? And then how about radians? Well, it's a whole bunch of 30s, right? What are 30s really?
Pi over 6.
Pi over 6s. 30s are pi over 6s. So then, this is a whole bunch of pi over 6s. 1 pi over 6, 2 pi over 6, 3 pi over 6. If you can't do anything else today, you need to be able to break these up into like a whole bunch of pi over 6s. 4, 5, 6 pi over 6. 7, 8, 9 pi over 6. 10, 11 pi over 6. Because that's the hard part for people. Most people can do the degrees easily because you're used to the degrees. That's not new. The radians are new and therefore more challenging. All right. On the next page, it's going to ask you for the quadrants. All you have to do is add in the quadrant first. By the way, if they'd asked that, what quadrant are we in right here? Yep. Would you have understood it if I'd have said that? Roman numeral 4. All the problems on both pages, but be happy I didn't go. Yes. Page 27, the first 2 pages of day 2. The very first problem started with 330. It's actually said, what, number 9 was the very first problem? Okay. And those 2 pages, they're basically just about coterminal angles, and they throw in a little bit of what quadrant are you in. All right, but you know from what you just experienced that you could actually, if you wanted to, find sine of 330 now. I showed you that. I'll remind you tomorrow. That's why I pre-taught it, because it's a tough lesson. All right, that's all I got for you.